So now we have a math problem that we can work with, so I can show you the check. And I promise you that at first the check is going to be like, what in the world, Miss Rostrom? I promise you, pinky pinky. But if you keep doing it and keep practicing, you'll get really good at it. And then you'll come back to me and say, Miss Rostrom, that was really easy what you taught us. And I'll be like, ain't that weird? Because don't I know? All right? So it's going to seem weird and it's going to take a while to get used to, but I promise if you practice it through our area model, when we do the other three, you'll be like, oh yeah, I got the check. Plus, the check helps you practice your multiplication and adding, which is important. All right, so I'm going to explain the check first. So now on the right-hand side, where your big X is what you're going to write this part. So your problem should have been on the left-hand side. And you have a huge X on the right-hand side. And this is where you're going to write the information that I write down on that side, okay? So on the top of our X, and I'm going to go through and explain it, and then I'm going to show you how it works. On the top of our X, we are going to have the sum of the multiplicand digits. Okay, so you are going to write the sum of the multiplicand digits. What does the word sum mean? What kind of answer is that? It is for an addition problem, right? So if we're going to do sums, we know that we're going to add. So these are some things we should be paying attention to. This is going to mean add. And what are digits? There's 0 through 9, right? On the bottom, you are going to have the sum of the multiplier digits. Okay, so you're going to have the sum of the multiplier digits on the bottom. And sum means we do what operation? We are going to add. Okay, and digits means numbers 0 through 9 digits, and they're all single. Then on the right hand side, we are going to have the sum of the product digits. Okay, so sum once again means add, of the product being our answer to our multiplication problem, and it's digits 0 through 9. Okay, this is when it gets a little bit confusing. I mean, it's going to seem confusing, but it's not confusing. Over here, we are going to have the sum of the product of the multiplicand by, and by means multiply, remember, the multiplier digits. Okay? So This one is the product of, and product means multiply, the sum of the product of the multiplicand by the multiplier digits. And what that means is, whatever number we get here, the sum of the multiplicand digits, we're going to multiply it by the sum of the multiplier digits. And then we are going to multiply them and then add those digits up. Okay? So it seems like it's confusing right now, but it's not. You're going to take this answer, multiply them together. That's why they're in the bottom and top of the X. And then you're going to add those digits up. Okay? There is one small little rule for this. All of these numbers have to be single digit. Okay? So this is also going on the right hand side. Underneath the X, there's room. They must be single digits. Okay? I'm sure you're like, that doesn't make any sense. But we're going to try it right now. All right? It's super, super cool, you guys. So, on the left-hand side, now we're back over by our problem because we're going to practice this. On the left-hand side, we have our answer. We have our multiplier, a multiplicand, and we have our product. That means that we can check it. Once we finish our multiplication problems, we should get into the habit of checking it. If you don't do this, I'm going to make you do the division problem. And trust me, you're not going to want to do the division problem. So, what we do is we get the sum of the multiplicand digits. What we're going to do is we're going to take our digits. We have 5, 9, and 4. We're not looking at them as 500, 990, and 4. We're just looking at them as digits, single digits. So if we're going to take the sum, we're going to add them. We go 5 plus 9 plus 4. Okay, so we're going to take them and do the sum of the multiplicand digits. Well, I'm going to add 5 plus 4, which is 9. And then I'm going to add 9 plus 9, which is 18. Well, I can't have 18 because my only rule is that it must be single digits. Okay? So what I then have to do is I have to take the digits of my answer and add them together. So then I'm going to take 1 plus 8, and I'm going to go 1 plus 8 equals 9. And that's a single digit, so it works. So I drop it into my check. So what I did was I took my multiplicand, I split it into 5, 9, and 4. And then I added these three together. I added 5 and 4, got 9. 9 plus 9 is 18. Remembered my rule. I could not put 18 here, so then I had to add 1 plus 8. So everything's coming from something we already have. I didn't just add like 3 plus 12 or whatever. No. I just added the number that I got to get it down to a single digit. So you just keep adding the digits until you have one digit. All right? Then we're going to take the sum of the multiplier digits. So we have 7 plus 8, which equals 15. But I remember my rule, it has to be a single digit, so I'm going to take 1 plus 5, which equals what? 6. So that's a single digit, so that works. Okay? Then I'm going to take my product, which is my answer to my multiplication problem, and I'm going to add those digits up. So I'm going to go 4, 6, 3, 3, 2. And I'm going to add them all up. So I'm going to go 4 plus 6 is 10, and I'm going to hold on to it. And then I'm going to go 3 plus 3 is 6, plus 2 is 8, plus 10 is 18. but I can't have 18. So I'm going to add 1 plus 8, which equals what? 9. Okay? So remember, I just took the digits, boom, 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 and added them up. Multiplier digits, multiplicand digits, product digits. And if they were double digits, then I just added those two digits together. And if they still equal double digits, I would just keep adding until they were down to 1 digit. Now here comes the tricky part. It's not tricky, it's gonna sound tricky, but it's not. You take the product, you take the sum of, so we're still taking the sum of, the product of these two numbers. Product means what? Answer to a multiplication problem. So we are going to multiply 9 times 6. 9 times 6 equals what? It equals 54. So I took 9 and I multiplied it by 6 and I got 54. Well, rule says I can't have double digits, so I have to add 5 plus 4, which equals what? 9. And here's how you know, if you're like, Mr. Russell, we have all this information, what do we do with it? Here's how you know if your answer is most likely correct. It doesn't mean it's 100% correct, because you can have zeros. Say you don't have these zeros, the values of the numbers still add up, because 0 doesn't hold a value. So if I didn't put a 0 here, and I got an answer, if I added all these digits up, I'd still get the same, I would still get the same sum, okay? So the check means it's most likely correct. Doesn't mean it's 100% correct, but wouldn't you rather be most likely correct than I don't know? Yeah. So here's how you tell if you are right, is if these two numbers are the same, okay? So if your product and your sum of these two are the same. If these two side ones are the same. So these two have to match right here. And these are the same, that means our answer is most likely correct. So I'm sure you're like, what in the world? We're gonna do it again. Okay, so I'm gonna put up the problems that we worked on Wednesday for our area model practice, and we're going to check them.